Good afternoon, everyone. Thanks for joining us, and welcome to our session on how Northwestern Mutual shifts left and shields right to stay secure on AWS. So today, you'll get to learn how NM has partnered with Sysdig to identify and prioritize vulnerabilities, improve security, and accelerate threat detection and remediation. So I want to thank you to AWS, or thanks to AWS, and thanks to all of you for being here today. So my name is Dave Vandermoss. I've been at Northwestern Mutual for a little over 14 years now. I lead a cybersecurity team full of engineers that help provide secure patterns for application teams, and we also deploy automated controls to help protect our container and cloud environments at NM. Now, outside of work, I must say I do love supporting, or I love securing clouds at Northwestern Mutual, but outside of work, you'll see me maybe on the golf course, riding my bike, or out in a trout stream fishing. So if you see me outside of this session, feel free to ask me about any of those things.
And I'm Jason Clark, who accidentally hit the button to advance the slide. I apologize for that. Did I? All right. So I work with large enterprises all over the United States to help realize value on the Sysdig CNAPP platform. We'll dive into a little bit about what that is and what it means to NM. A little snippet about me is a Vegas-related fun fact. In 2004, there was a conference called TGIF, Toy and Game Industry Foundation, where my toy that I submitted, a children's toy, won first place. It didn't get picked up by Mattel, Hasbro, Whammo, any of those guys, but nonetheless, kind of a fun little fact.
So what we're going to go over today, I'm going to talk about Northwestern Mutual, our cloud journey and security transformation, and how we're leveraging AWS and Sysdig to solve some key challenges related to container security. Jason will also dive into who Sysdig is and the capabilities they provide that help solve common problems that we all face in container environments.
Yeah. And albeit NM specific, we're going to make it as relatable to you guys and some of the similar challenges you might be facing across your organizations. So we'll be drawing those parallels and helping you understand the art of the possible.
So who is, or what is Northwestern Mutual for those of you that aren't familiar? So we're a financial services company. We provide a holistic approach to financial planning through insurance and investments. We are over 160 years old, and I looked this up the other day. NM was founded roughly 9 years after the state of Wisconsin was founded. So very old company, very neat that we're in the cloud space, very innovative, great place to be at. Now we have roughly 7,000 home office employees supporting well over 9,000 financial advisors throughout the United States. So you may see in larger cities in the US, Northwestern Mutual branded buildings. Those are most likely be the financial advisor offices throughout the US. We are headquartered in Milwaukee, Wisconsin, with a small presence in New York City as well. And I must say I'm very happy to be in Vegas. When I left on Sunday, there was snow on the ground. And when I looked at the temperature this morning, it was about 15 degrees. So very happy to be in this 50-degree weather with lots of sun. Feels like shorts weather.
Great building, by the way. If you get out to Milwaukee, be sure to visit it. It's right in the heart of downtown. You can't miss it. And actually, a wave or a shout out to the people back at their headquarters who are doing a watch party right now, which I thought was a pretty interesting concept. I think it was pretty cool that you guys do that. You're not there. I'd rather you're here on stage with me, but for those of you watching live, that's pretty amazing.
So I'm just going to briefly go over NM's cloud journey. You can see we started back in 2015. I can't believe it's been 8 years already. So we were early adopters of Kubernetes. So what I would consider, so in 2016, what NM considers to be production-ready Kubernetes, we were already self-hosting clusters there. So in 2018, you can see labeled the Cloud 1.0 platform launch. NM actually had a multi-cloud strategy. Now, what we learned within the couple of years after that, that's not a very sustainable model. And in 2020, we consolidated down to a single cloud, first being obviously AWS. So we were able to focus more on providing more mature delivery pipelines into our AWS and Kubernetes environments. In 2021, we migrated to EKS. So prior to that, we were self-hosting our Kubernetes clusters in AWS. I was a part of that team prior to the move to EKS, and I must say it was helped us immensely just from the upgrade process, and for the Kubernetes operators here, managing etcd clusters is never fun. Now in 2022, we have this cloud-first strategy where for new applications that are being developed or being refactored, our strategy is AWS first here. And so this has been an evolving strategy. When we first started in 2015, it was more of like a startup type mentality, a very smaller team, but we've scaled this more to the enterprise with more standardized patterns and made it easier to deploy into AWS.
And you're one of the OGs there. You've been there, what, 2008, 2009 timeframe?
Yep, quite some time.
I guess what, in your time there then, what is the sort of biggest impact to the business that you saw through this journey?
So I know the big thing that comes to mind is the improvement in resiliency. So even with our EKS clusters being able to be multi-AZ, so we have data centers in Milwaukee, and so just being able to utilize AWS's infrastructure, our clusters have become more reliable. Also just the security that we get out of AWS, some examples that come out of mind are gonna be the DDoS protection out of AWS Shield. So our workloads that are fronted by cloud fronts or application load balancers, we can take advantage of AWS's DDoS protection, and also AWS WAF as well. So these are just inherently secure patterns that AWS provides that we've been able to consume much easier. And the last thing I can think of is being able to use emerging technology like generative AI. So I know Bedrock is a newer service, but it's allowed a company like NM, that's over 160 years old, to get into the Gen AI space.
This is a little bit of a high-level diagram in terms of how NM's infrastructure sort of plugs into our Sysdig SaaS backend. We're not necessarily going to dive into this. For those of you interested in terms of like our architecture or how we instrument, we can dive into some of those conversations perhaps after the session. But Dave, I would want you to mention at least a little bit about some of the applications that you're protecting.
Definitely. So we have a number of different types of applications or workloads. So the first one being client-faced. So if you're a customer of Northwestern Mutual, you want to check your investments, you want to check your life insurance policies. These applications are very critical to the business and are hosted in our EKS clusters. We also have applications that are financial advisor focused. So the financial advisors are using these applications in order to help their business grow and help provide a better experience to the NM clients. And lastly, we have homegrown applications that I would consider more back office or that are used internally to support the overall business itself. So a number of different applications or types of applications, and the criticality will range from very low to very high. So a very general range.
Got it. Thank you.
So I'm going to talk a little bit about the security transformation at Northwestern Mutual. So the goal that we have defined here is not just a goal, obviously, that we have strived for at NM, but I'm assuming most everyone in the audience here, obviously to deliver a world-class cybersecurity and risk management services. So one way we've done that is building a security culture. So we do believe people are the first line of defense. It's very important that we found to educate application teams and developers and creating a sense of ownership of what they have deployed into AWS. So what's really helped NM in this area is actually our implementation of an internal program where we train developers on AWS, DevOps basics, how to deploy AWS services through automation, and how to deploy standardized containerized applications into AWS. So this helps elevate our application teams and also gives them more of a sense of ownership. So now, secondly, we have establishing rigorous security processes. So as I mentioned earlier, there's a high importance of automated controls that we have deployed into our clusters. So having preventative, detective, and reactive controls in our cloud and container environments helps us achieve this. Now, some examples of this when I mention these types of controls. So we have things in place such as if a developer tries to deploy like an S3 bucket or something like this that's unencrypted, we'll know within minutes and we can automatically delete that bucket. So we have these policies for cloud resources like that. And also from the container side, we have policies in place that will prevent, think of a container running as root. So completely prevent that from running, or even if an image is sourced from a public repository, we can block that from being applied to the Kubernetes environment. So lastly, on this slide, so continuously evolving and improving. So as we all know, the landscape, like the security landscape is continuously evolving, and it's very important for us to stay up to date on this. So we have teams, so while we have internal teams that are helping focus on this, we have relied on Sysdig as part of this, especially with their managed security policies. So it's hard for me to be an expert in everything. So we've really leveraged Sysdig's expertise from the type of security threats and runtime policies, and really have relied on them to help elevate us.
One thing, I can appreciate this slide. I'm a huge fan of culture. It's part of the reason I went to Sysdig in the first place. I'm going to put you on the spot a little bit, but do you have any like stories or anything about the security culture and how it's actually being played out within your org?
So one of the things we do, we make all of our vulnerabilities visible internally to our application teams. And what I have found with some departments is actually, I wouldn't call it gamification, but we have almost some competitions, or we have leaders between departments that are trying to have the least amount of high vulnerabilities in their application. So it's kind of been a fun and interesting thing to watch play out. So, and it helps us reduce the amount of vulnerabilities that we have in our production environments.
All right, let's dive into who is Sysdig. You got to learn a little bit about NM. I want to take some time to lay the foundation of who Sysdig is, how we solve things a little bit uniquely. On the left there, we are builders, at heart. We innovate on a number of open source technologies, a lot of which we've contributed to the, to the CNCF or to the community at large. Who here, by way of hands, have used Wireshark? Almost all of you. I sort of figured as much. So our CTO and co-founder, Loris Dejuani, was one of the original creators of Wireshark. So when he was setting out to tackle this new challenge of cloud-native application protection, he thought of it in the sense of like, what is going to be my source of truth, similar to a packet. In this case, he landed on the system call. So the first, sort of iteration of Sysdig was in 2013, the open source Sysdig kernel module. Again, we could talk about how we instrument using eBPF and through KMods and things like that, but ultimately that was his source of truth, and then he needed, a way to use that telemetry data and make sense out of it. So then he created Falco. If you've taken the CKS exam recently, about 20% of the weighting is actually on Falco detection and response capabilities. So that was a project we donated to the CNCF in 2018 and is quickly becoming the de facto standard for runtime threat detection. We're able to take advantage of the Falco community at large, the massive numbers of contributors. It's been downloaded over 75 million times. And there's actually Falco projects that we can take advantage of. So when we get into the runtime threat detection and response portion of this, we can dive into some of those projects, but it's taking telemetry data from other sources like CloudTrail logs, from Okta logs, GitHub logs, et cetera. So that's sort of how we started. And then on the right is essentially a depiction of high-level architecture type diagram, right? But what it's showing is the unification in the CNAPP platform to take insights from the running environment and then feed it into other areas like posture, configurations, and permissions that you can do agentlessly, blend that with insights that you can get from the running environment. And we can do so by getting cross-domain correlation, so containers, services, entitlements management, and then essentially feed that into, in the center there, that cloud attack graph. And that gets you things like in-use permissions, it gets you insightful data into vulnerabilities, like things that are actually in use on a running container. So we'll be going specifically into this a little bit more further on into the presentation. Here's a few things that we're going to focus on. These are not just the core capabilities of Sysdig. These are three that we're sort of going to be focusing on today. So with vulnerability prioritization, we're going to go specifically into some use cases that Dave will be talking about. But some of the things that you see there, reduction of noise, identifying and prioritizing vulnerabilities, sorting those by risk factors, things like that. For Kubernetes and containers, using audit log information that you can overlay onto the telemetry data, being able to measure the improvement that you're seeing from a security perspective. And then on the advanced threat detection side, the transparency that you get, we'll dive into Falco a little bit, getting all of this information in real time is extremely important. And then just being able to use context that we give you to be able to do an effective incident response. So those are the kind of the three pillars that we'll be talking about today.
And one thing I'd like to add on to this, the at scale comment here. So we cut over to using Sysdig earlier this year. We have clusters, 1,000 node plus clusters, and Sysdig has been able to handle this scale from a vulnerability and runtime threat reporting perspective. So it's been a great rollout that we had, and as far as stability as well. So now we're going to talk about some cloud and container security challenges that not only Northwestern Mutual has had to deal with, but I'm assuming most folks in the audience here. So the first one's around reducing vulnerability risk, and what I mean by that are a good example. So if you have a Node.js application, there's over 2 million Node.js packages. These are all third-party open source. Any given Node.js application could have thousands of these packages included in their application build. All of these packages could contain vulnerabilities. So we had to come up with ways, or you have to come up with a way to help reduce the amount of vulnerabilities that you introduce into your production environments, or even completely mitigate or prevent that from happening. Another big challenge is around eliminating misconfigurations. I touched on this a little earlier, but container running as root is a good one. There's a lot of configurations that a developer or an application team could change that inherently make it not secure anymore. So we really need to be able to detect on these misconfigurations, ideally prevent them prior to deploy. But if it's not something that we can completely prevent, we need to be able to detect on them at runtime and then report on them for remediation after that.
Another challenge, we kind of touched upon it briefly in the previous slide, but just detecting threats in real time. If you're doing static analysis, or if you're doing, using agentless technologies where you're not getting a live look at what's going on in your environment, there's usually a visibility gap. Like if you're getting detections every 15 minutes or an hour or 24 hours, it's too slow. The sort of average attack time in cloud environments now is usually less than 10 minutes, so you need to be able to respond to these threats in real time. You could actually check out sysdig.com/555, which is a new framework that we're rolling out, which essentially says detections within 5 seconds, initial response and correlation within 5 minutes, and then a response within 5 minutes. So it's essentially 10 minutes within that kind of attack time frame. And then improving the response effectiveness, right? It's taking, in that multi-domain sense, it's taking context and information about the attack, and specifically, so that you have the relevant information and being able to tie perhaps disparate events that might be chained together to be able to get your environment. So it's all about like improving that response effectiveness. And that little stat at the bottom I thought was pretty interesting too. 72% of containers live fewer than 5 minutes, and I would hope that none of you are, plaguing your environments with long-lived containers and just taking monolithic apps and shoving them into a container and say that you're containerized. I would argue you might not be doing cloud right, but Dave, in your opinion, like how has the ephemeral nature of, these applications affected, security in general?
Yeah, I mean, it's very important to be able to catch a security event, and obviously going to this containerized environment, like you mentioned, these containers are so short-lived that these security events need to be captured, and Sysdig allows us to do that in real time and report into our SIM, which I'll touch on a little later. So now I'm going to dig into one of our use cases here, addressing vulnerability risk, now specifically around our pipeline deployment processes at NM. So this little statistic here, 87% of containers have a higher critical vulnerability. This goes back to how can we prevent, or from the first place, how can we prevent these vulnerabilities even getting into our production environments? And also, like, if they do get into our production environments, how can we get them remediated as fast as possible? So this diagram on the bottom, obviously you can see there's a developer, an application team that cuts a feature branch in GitLab, GitHub, whatever. They commit some code, they push up to their branch, and now at NM, our deploy pipelines are standardized, and in order for an application team to get into our Kubernetes clusters, this is the only way to do that. So we require, and what you'll see after the Docker build, we do require a security scan using Sysdig. So a team doesn't have a way around that. So after that container is built, we do that Sysdig scan, And if we actually see a high vulnerability being reported in that container, we completely block the pipeline, fail the pipeline. Now, we do allow developers, there's basically two solutions to this. The first one's obvious. The developer has to basically make an update whatever package. Maybe it's a Node.js package, a Python package, whatever. Could be something related to Alpine, Debian. But they actually remediate it, fix it, push it up to their branch, and obviously this goes through the same process again. And then if it passes that Sysdig scan, we allow the deploy process to continue. We also had to implement basically a risk acceptance process as well. There are scenarios where an application team basically will just accept the risk. So prior to us implementing Sysdig, the technology team or my area was more or less risk accepting these vulnerabilities. We've shifted this onto application teams. So if they want to deploy something that has a high vulnerability, they do have that option, but they are taking ownership of that within our risk system. So since we've rolled out Sysdig into our environment, you can see we've had over 400,000 scans. Now this number is a little out of date because we had to submit this a few months ago. So this is probably closer to 600,000 scans. And then we've actually stopped over 17,000 pipelines out of those that had a high vulnerability. So that's one of our ways of us completely preventing these vulnerabilities from getting into production. Two other things I wanted to touch on that aren't depicted in this slide. We found that it's very important to have an admission controller. So OPA is a popular one. Sysdig actually offers an admission controller as well. Some advantages of this is you can require a Kubernetes deployment to have specific annotations. Now at NM, applications are basically have an identification number which ties them to owners, ties that to a security categorization number. So we require specific annotations on a deployment, so then we know who owns this container that just got deployed. An admission controller can also help prevent things like using a public image from a public repository. So by doing this, we're forcing teams to use our private repositories, which also go through these Sysdig security scans. And one other thing would be, I had touched on how many Node.js packages there are. Using something like Renovate, which is an automated dependency updating tool in your environment, has been very helpful for us. You use this tool, it runs on a cadence, it looks at packages in your repo and will automatically create MRs. And if you have sufficient enough testing, you can actually have these MRs auto-approve and auto-deploy as well. So that's also helped reduce some of the churn for application teams.
Even though this is a picture of our user interface, you don't have to live in the user interface, so don't worry about always having to come here and look at fancy diagrams and things like that. You could take, as NM does, they actually take our vulnerability data, feed it out into their enrichment process, ultimately into their SIM and things like that. Or if you guys are using ServiceNow, you could use that as a vulnerability response module and take the information that would get you through API into the tools of choice. But one thing I wanted to talk about is just how we, Sysdig, handle vulnerability management in general. It's an intentionally overlapping set of capabilities. So think of it as a way, like what we deploy is an independent binary that acts as our scanning engine. That scanning engine can be used independently by developers. So run it on your workstations, do ad hoc scans using the same policy enforcement that you're doing across your pipeline or in runtime. So you can do those ad hoc scans. That same scanning engine can be plugged into your pipeline, similar to what Dave was talking about. You can use it to scan your entire registry. It's the same scanning engine that's used in runtime. So anytime a container hits runtime, or you're scanning your host as well, but once it hits runtime, it'll do a constant reevaluation against policy to make sure that new CVEs haven't been introduced, new fixed versions available, things like that. And as Dave mentioned, we also have our own admission controller. So what that's doing is enforcing policy and sending a validating webhook back to the Kubernetes API to make enforcement decisions as well. So it's intentionally designed to be, overlapping, and then you can use it wherever you want within your software development lifecycle.
So the next couple of use cases I'm going to talk on are around runtime reporting, around fixable CVEs. And so basically CVEs are vulnerabilities that have a fix available. And then also what I'd consider a compliance or misconfigurations. I know I've hammered this home a few times, container running as root is one of them. So from a runtime perspective, we want to be able to catch these high vulnerabilities if they get passed and deployed into our pipelines. Now, I know on the last slide or the last use case, we do block high vulnerabilities. Obviously, not every application team is deploying on a daily, weekly basis. There's teams that might be deploying on a monthly basis, and so these are longer running containers that we don't like to have, but they can accrue vulnerabilities. So we need a way to be able to report on these vulnerabilities and actually have action from the application teams to remediate. So in this diagram here on the left, you can see there's a depiction of an EKS cluster with Sysdig, and that's essentially just saying Sysdig's running as a daemon set in our clusters to be able to watch everything that's happening. Now, outside of the clusters, we have created this custom process. The little Python icon essentially indicates a cron job that we run on a cadence, and it's actually collecting all of the vulnerabilities, so all the CVEs of running containers, and all of the compliance issues, so things like container running as root. We're enriching this data. So I mentioned how we have an identification system for each application. So we're able to identify, hey, is this a high security application or is it a low security? We'll actually increase the severity of a CVE if it's a critical application. So think of maybe an internet-facing application. We're also assigning ownership of this vulnerability, and we're also setting due dates. So we have internal SLAs, so think if it's a critical CVE, we're setting a due date out 14 days. So if a team doesn't remediate that within 14 days, we actually will automatically open up a finding in our risk system. So all of this enrichment that we do on a nightly basis, we throw into Redshift, and then we're able to visualize in a dashboarding system. And one of the reasons we do this is because we have many security tools, and we have a similar pattern where we'll aggregate all of this data into a central Redshift environment, and then we can visualize it in one single environment instead of forcing application teams or developers to go out to 6 different tools in order to view all of their security issues. So what this has really created is visibility for application teams to be able to see vulnerabilities and misconfigurations in their environment, and it creates action on them to remediate them. And it is very important, that risk manager icon, to be able to tie overdue vulnerabilities into your risk system, because that's where the minute teams start getting all of these risk findings on them, that's a bad look, and you don't want that. So it causes teams to try to fix these right when they see them. And one other thing too is when we open up new vulnerabilities, we have this in-house notification system where we'll actually notify the application team that's responsible, saying, hey, you just had 5 new vulnerabilities on this container in this cluster. So that helps bring more visibility to it as well. And some of these numbers you can see, so we have 99% of our containers are not running as root, and that's because we're able to detect on that, we're able to report on it, and then get compliance as well, or get teams to remediate that. And you can see we've had 1,000 plus high vulnerabilities found at runtime, and so these are vulnerabilities that are active in the environment that then teams that are assigned an SLA, and then teams are responsible for remediating.
All right. This is a view, just that use case that Dave was just talking about, so a container running as root. This is a view into how we do that and how we streamline the remediation. So I'll talk about a little bit of how we do that. Number one is you have your underlying requirements, be it HIPAA, high trust, PCI, CIS, whatever you guys are using to as kind of best practices, be it compliance related or otherwise. What we used OPA for, whoever's used OPA before, you probably do not like Rego, I would argue, which is kind of a pain to learn. And so what we've done is we've taken the requirements for all of those, again, posture controls, et cetera, and we've broken them down into their individual controls. So think of it as like an individual control would be to do an automated check to find out if you have containers running as root in this example. What we'll do is we'll identify those, and we can attach a remediation playbook to the individual control. So think of that as an opportunity, since you have all these custom controls, to create your own set of standards. If you want to deviate from NIST, for example, and you wanted to create your own controls or your own requirements, you can use those custom controls to be able to do that. And with that remediation playbook, what we're doing is we're then helping you prioritize risk by identifying containers, in this case, that are running as root, and give you almost a query against your overall inventory to say, of the 250 containers you have, 83 of them which are still running as root. And it could be human error, somebody could have fat fingered something, somebody could have forgot to set the value, therefore it's going to default to a root container. So then on the right-hand pane, you'll see is a way to create a patch I just entered an arbitrary value, 1, 2, 3, 4, so it's creating the patch for you that you can either download and run the kubectl command, or better yet, connect it up to the Git source and then open up a pull request. Therefore, the person can review that. Sysdig would have provided the findings into the tool that you're using, and then that person can choose to merge the pull request if they want. So it's all about prioritizing those findings, making it easy to identify where you have failures, and then streamlining the remediation.
So one of the last use cases I'll talk about here is addressing threat detection and response. So obviously Sysdig can help us detect on all of these different types of runtime threats. So whether that be system calls, network and file system activity, malicious processes, and also can collect, or does collect, EKS audit logs as well. So calls being made to the Kube API server. So all that's being collected. And so obviously we have all this data, so what are we going to do with it? So Sysdig allows us to send all of these events into your SIM. And then from that perspective, inside of Northwestern Mutual, we have a threat detection and response team that will then write essentially alerts or modify some of these detections to basically identify and react to some of these alerts. And from a runtime threat, some of these things that we're looking for are reverse shells, fileless, I forgot that one. Like launching privileged containers, clearing log activities, mounting privileged containers with mounts. So there's all these different type of runtime threats that Sysdig manages for us as far as the type of rules. I know Jason had mentioned Falco rules. We do have the ability to write our own Falco rules. We try to avoid that as much as possible. We want to take as much out of the box from Sysdig as possible. So from this, you can see on the statistic up here, so at NM we have 14,000 plus containers that are running across, I believe now it's a little over 30 EKS clusters. So prior to us implementing Sysdig, we didn't have any of this visibility. So this has really helped us at least get full visibility into our EKS clusters, and then we've worked with our incident response and threat detection team to actually react to these and take action. It's been super helpful.
All right, so our approach to, there's a lot that we can get into. This is kind of our sweet spot. This is an area that we've built Sysdig upon, right? When I talked about how we instrument, I talked about Falco a little bit. This is an events overview page just to kind of get you a sense of some of the things we're doing. Number one at the bottom, like we're enriching every finding that we have and we're aligning that to the MITRE ATT&CK framework. So if it's defense evasion or looking in and doing recon, whatever the case may be, we're taking a security event and then mapping that out for you. So if you're looking at the blast radius of a potential attack, you want to understand related events, you can use that framework to help you achieve that end. Dave, you mentioned manage. We have our own Sysdig threat research team. So all of the policy, well, first off, the rules that you get with Falco are all given to you out of the box. You can customize them. There's the sense for any of you that know Falco, you can get into the rules editor. You can use the macros and lists to your heart's content. However, you don't have to because our Sysdig threat research team is curating that list, constantly updating it, applying those rules to manage policies. So you get a lot of value right out of the box just simply by turning Sysdig on such that you can have those detection capabilities that Dave was talking about. For any of you interested, if you were to ever evaluate Sysdig from a software perspective, who's heard of Atomic Red Team? It's a pretty interesting project where they're actually building out simulations for all of these different attack types, and we wrapped that and create what we call the Sysdig Threat Generator. So it's a way for you to kind of put your existing tool set or your existing visibility mechanisms to the test to see if you're actually getting accurate detections against some of these advanced threats. Some other things we have, Kubernetes Live, which is essentially a 24-hour view into your Kubernetes environment to help you understand exactly what's going on in real time, like I talked about, or everything that's occurring within the last 24 hours. We have Falco projects, like I told you before. So when you think about the different policy types that we have, workload policies, audit log policies, we're also taking Falco projects. So we just recently rolled out a couple new ones, which is to take and analyze all of your Okta logs so you can get detections for anomalous activity within Okta. You can do so with GitHub and different Falco projects that we're able to take advantage of. Then there's also the response actions that you can take. For every policy, you get the opportunity to determine, all right, if we find something, what are you going to do about it? Is it kill, stop, or pause the container? If it's container drift, do you want to actually surgically terminate the rogue process? Because what we'll do is we'll actually look at the intended state of a deployed container and then measure that against anything that has drifted from that container drift perspective. We're also doing malware detection that we can actually terminate any identified malware within your environment. So there's a ton of different capabilities. And then once that happens, is you can take advantage of event forwarding. So just like NM is doing, they're taking the events that we generate, feeding it into your SIM if that's your source of truth, and then determine how you want to take action on that. And so we can dive into some of these specific use cases, but this is just a quick glance at that.
So some of the things that NM is looking to do to further integrate with Sysdig in the future. So this top one's around automation. So I'd mentioned being able to write custom Falco rules. So our threat detection team wants to do that. And you can do this in Sysdig's UI, but we at NM try to do everything in code, even if it's managing a vendor's tool. So what our team has started to do from a POC perspective, we started using Sysdig's Terraform module to actually create essentially a process to allow our threat detection team, if they want to create a new Sysdig Falco rule, they submit an MR to a specific repo, we review it, we deploy it, and it's out there. And then we will deploy it out to our dev environments and then our int and QA and then production environments. But all of our Falco rules that we're going to write custom are all in code. So we have everything with a history of the Git log. So some of the other integrations that we're going to look at is the registry scanning. So you can integrate Sysdig with your private registries. So we want to integrate this in order to speed up some of our deploy pipelines. So essentially, that will keep a warm copy of the results of a container instead of having to scan it on demand at build time. We also want to take advantage of the host reporting. So we run a very slimmed down container operating system in our EKS clusters. Our previous tools did not support that, and fortunately Sysdig does. So we're going to actually take advantage of reporting on host vulnerabilities. And then one of the things I didn't really touch on yet is this in-use feature. So Sysdig is able to determine at runtime packages that are loaded in memory and actually being used by the application. So this really will allow us that initial statistic, that 87%, this will cut that down. And so what we want to do is actually use that in-use feature to be able to set an even shorter SLA. So if it's a high vulnerability that's actually in use, we potentially want to set a less than 14-day SLA on that. So that's going to be a very useful feature that we want to implement in the future.
Little animated GIF for you here. So we'll probably have to watch it a couple times because it goes fast. But essentially what this is doing is it's a sort of prioritized view of risk. And once this kind of cycles back, you'll notice a couple things like the in-use feature, the live security events that are happening. And then this is kind of a stack-ranked view of the criticality. So the one you see up there at the top, the critical one, has a number of different vectors that increase that criticality. It's publicly exposed. It has multiple vulnerabilities that are actually in use and have fixes that you can take action on. There's actually live security events going on. So ultimately what you can do is dive into those workloads that are being affected in that sense, look at an overall attack graph to understand where do we get the information. It's all of that context to be able to help build an effective response. And it's through having the live look, it's by having the in-use context and data that you wouldn't be able to get if you didn't have an agent running in the environment. And so we were talking about the challenges, and then ultimately on this next slide is some of the benefits that you get, right? So if you'll notice kind of category by category, by having runtime insights on the left with posture management, you're able to be able to detect drift. So if you've intended for something to be configured a certain way and you want to identify, did we change something? Did we drift from that base posture or that configuration? You'll be able to identify that in real time to be able to make the effective change like we talked about with the streamlined remediation. With vulnerability management, you're taking a look at not only the CVEs themselves, but whether or not there are active exploits against those. And we're using that flag, that in-use flag, to say on a particular running container, it's actually been loaded into memory, so therefore you should look at this and prioritize this above all others. So that will help in Dave's sense to speed up the amount of time, reduce the amount of noise that he's getting within the environment to help kind of sort through that. And then the entitlements management side, looking at permissions across your environment of things that are unused, what are people doing within your environment and how might they be, quote unquote, kind of abusing the cloud environment. And then on the detection and response side, it's again back to that real-time view. So less than 2 seconds to be able to identify what's going on within your environment is extremely necessary. And this, we put these stats on the slides before, but we wanted to emphasize, and again, AWS makes us submit content, as you can imagine, a little bit beforehand. So I think that number's up to like 600,000, 700,000 scans. But it's no small number, right? Like the amount of measurable benefit that you can get simply by using Sysdig and being able to put the processes that NM has into place, it's really nice to see these numbers up on screen as a measurable outcome of this. When I do evaluations or work with customers like you to evaluate our software, we also have like a business value assessment that we can do where during an evaluation of software, it's often important to have measurable outcomes so you can say, it's better than it was before, and here's the difference, here's the delta. So to be able to measure that like this is extremely important. So just sort of a little kudos to NM and some of the measurable benefits they've gotten by using our software.
So really the outcomes at Northwestern Mutual, so everything we've talked about, whether that be preventing vulnerabilities from getting into our environment, reporting on vulnerabilities that are already there, and also getting all this data into our threat detection team for them to act on. We have full confidence in protection from all these runtime threats. I mentioned we had no visibility prior to this, so this has been a huge win for us. And also I mentioned that program earlier on where we train our developers and we create the sense of ownership. So it's really helped us for application teams to take ownership, whether they're risk accepting, whether they're remediating these vulnerabilities. It's been a big step for us to be able to create that ownership. Thirdly, the full support for in-use operating system and languages. In the past with tools, we haven't had full support. Now, whether there's a team deploying JavaScript applications, Python, Node.js, whatever, we have full support of that, and also the operating systems as well, whether that be x86 or ARM-based. So Sysdig supports a plethora of this, and we were, prior to this, we were actually missing some support from that. And lastly, we've had improved collaboration across our security teams. So I'd mentioned how we have this process in place for our threat detection team to be able to create these Falco rules in an automated fashion. Prior to this, that did not exist. So it's really helped us work with other security teams internal to NM and actually provide more, and I would say, faster services for these teams. So we want to thank everyone for coming here today. We do have a few mics that are live, so we're open to taking some questions if anyone has any at this time.